Activity Series Worksheet. This worksheet is about single replacement reactions. And you've already labeled these on prior worksheets, but now we're actually going to show whether or not they would happen and whether they are balanced or not. We're going to balance them if they're not. So we're going to figure out if a reaction will take place and then predict the products if it does and balance the equation when we're done. So in a single replacement reaction, remember, one element replaces an element in a compound. Pardon me. Now this will only happen if the element replacing it is more reactive than the one that's already in the compound. So how do we know which one's more reactive? Well, there's something called an activity series. So if you look at your reading material, Fun with Predicting Reaction Products notes, on number 4, it gives us this thing called an activity series, and it shows us the metals and hydrogen. Now this isn't all the metals, but it's the most common ones that are going to react here. So we've got hydrogen also is in there because it does bond with a positive oxidation number, so it does bond with the same things that these will also bond with. So we have hydrogen in there as well, even though it's not a metal. So we've got most reactive over here with lithium, and the least reactive over here ending with gold, Au. So what we do, and let me make it so we can see both of these at the same time, we're going to check these two elements. So here's K, and K is a positively charged element when it bonds. All right, when it's an ion, it'll have a positive charge, and zinc is our positively charged ion in this compound. The positive element always goes first, followed by the negative. All right, so positive ion, negative ion. So this positive will want to replace this positive. So I'm going to look up K. Here's K on our activity series, and I look up Zn. Here's Zn. K is more reactive than Zn. So this will happen. This is more reactive, so it will take the place of Zn and bond with Cl. So now what we have to do to determine what's going to form after the reaction, I need to write down the charges of these elements, the oxidation numbers, what they'll be when they bond. So K is in group 1 on my periodic table, so I know it has a positive 1 charge when it bonds. So here's going to be a +1. Now I know chlorine is a -1 because it's in group 17. It needs 1 to get to 8, like the noble gases. So -1 for chlorine. Now if you don't already have it memorized that zinc tends to bond as a +2, zinc is one of our transition elements. So remember that these do bond strangely, groups 3 through 12. But zinc tends to bond as a +2, and we can tell it's a +2 because since chlorine is a -1 and there are 2 of them, we have 2 negatives here that need to be canceled out by 2 positives. So I have here a +1 charge wants to come in and take the place of this +2 zinc. So K will bond with Cl. So I'm going to write my K, and since it's bonding with Cl, I'm going to check these 2 charges. K has a +1 charge, Cl has a -1 charge, so they're already going to cancel each other out to a charge of 0. So I don't have to cross over the subscripts to make this a proper compound. All I have to do is write KCl. Notice there are 2 Cl's here, but I don't need to put a 2 here because if I had 2 -1s, then I would need 2 +1s to cancel that out. I don't need that. I have +1, -1, they already cancel out, so I leave it the way it is, just KCl. Zinc gets kicked out on its own. Remember, since it's a replacement reaction, this got replaced and it's kicked out on its own like potassium was beforehand. So I'll put +Zn, zinc. Zinc is not one of the diatomic elements, so I don't have to put a 2 after it, so I leave it the way it is. Now, it's not balanced. I can see I have 2 chlorines here and only 1 chlorine on this side, so I do need to go ahead and balance my equation. So I'm going to put some blanks here so I can balance it out. And since I know I need 2 chlorines on the right, I'm going to put a 2 here. Now that doesn't just change chlorine, it also changed potassium. So I go over and put 2 potassiums on this side as well, and now I'm balanced. 2 Ks and 2 Ks one ZN and one ZN, two CLs and two CLs. If you haven't yet passed your exit level tax test, I recommend that you stay in the habit of putting ones in these blanks. It's not necessary. It is understood to be one if there's nothing in the blank. However, on the tax test, they would ask you, for example, what is the coefficient for zinc chloride when this reaction is balanced, and you need to know that it's 1. There is no such thing as just a blank answer on the tax test, so you need to know that that's a 1. Now, I've already labeled number 2 as no reaction, and let me show you why. Lead wants to go in and replace manganese. Pb is a positive charge, Mn is a positive charge, metal replaces metal. So I go in and I look up Pb, there's Pb, and I look up Mn, and there's Mn. This would have to be more reactive, because it's the one by itself. It needs to be more reactive than manganese in order for this reaction to happen. Because it's not, I've labeled this no reaction. All right, it has to be more reactive than the one that's in the compound in order for this reaction to happen. You don't have to do anything else at this point. You write no reaction and it's done, because there's no equation that forms for you to balance. So for the rest of these, you're going to do it the same way. Numbers 3 through 10, just go down, determine, is this more reactive, the one by itself, is it more reactive than the metal it's trying to replace? If it is, form the products by finding the charges for all the elements, and then balance it. If it is not more reactive than the one that's already in there, then all you have to do is write no reaction, and that problem is done. If you do still have any questions on this, please make sure you come ask.